So dear student, welcome to the class. So in this class we are going to solve one of the short question on a one-dimensional element. So here you can see the question on the screen. So this will be a short question for the competitive exams on a FEM. So here they have given the value of displacement if Q1, that is 0.1 millimeter. It means it is a one displacement. So generally the Q or U will be represent with the displacement. So Qi, it mean there is a displacement at one node, and Qj, so displacement at the another node, that is given as 0.2 millimeter in a linear one-dimensional element. So it is a linear element. It means having two nodes. So there is a one node and second. So here at node 1 and it is node j. So they have represent like I and j. So the displacement what one end, that will be taken as Qi, and the displacement at another end is taken as Qj. Or in another way it can be replaced with U1 and U2 can also be defined. Okay, so it is all based upon the textbook which you are referring. So it is a linear element having one-dimensional element with the total length is given as 250 millimeter. So the total length of the element is 250 millimeter. So now you need to calculate what is the strain displacement matrix. Okay, so generally when we are having the FEM subject, so very rarely they will use to calculate the strain displacement matrix for one-dimensional element. Generally they used to calculate the stiffness matrix they used to ask, or they used to ask the calculate the displacement. But it's a short question, so you have to use our tricks to calculate the strain displacement matrix, and also strain you need to calculate. Okay, so displacement matrix, strain displacement matrix is taken as B, and strain is epsilon in the, you need to calculate. Okay, so for one-dimensional element, what is the stress here? How do you define the stress for one-dimensional element, that is 1D bar element, where stress, that is sigma can be written as, it is the modulus of velocity into the strain displacement matrix into the displacement. Okay, nodal displacement, it will be defined EBQ, where this modulus of velocity, it is also be a material property. So again in another form it can be defined as dBQ also. Okay, because the material property can be taken as properties matrix, so D can be substitute in place of E. So any one you can use here, either EBQ or dBQ. So now let me see what are the things are given. So you need to calculate the B matrix. So first, how do you define the strain displacement matrix, that is B, where for the one-dimensional element the strain displacement matrix, it will be 1 by a small l into a matrix 1 into 1. So this will be strain displacement matrix. Okay, so where again you know the displacement, so Q1 Q2 will be the displacement, nodal displacement, that we can easily substitute. Okay, right. So how do you calculate the strain? Then this is second term you need to calculate. So let me first calculate the strain displacement matrix that we already know. B is equal to 1 by L in the bracket, in the matrix there will be minus 1 into 1. Okay, so it is an 1 into 2 matrix. So what is 1 by L? L is the total length of the element, that is 250, right? So again in the matrix minus 1, 1. So this becomes a strain displacement matrix. Okay, shortly you have to remember this one formula where strain displacement for one dimensional element is 1 by L minus 1 into 1. So this is your answer now. Okay, so this answer may be given in the optional, so you have to choose the best one. Now again we will go for this second one to calculate the strain. Okay, so strain you need to calculate. Strain is equal to what? Where epsilon. Okay, generally when stress can be defined as Young's modulus into the strain, is it? So where Young's modulus will be stress by strain. So now where stress is equal to Young's modulus into the strain. So the strain is equal to what now? It is B into Q, where strain is equal to B into Q. So B is the strain displacement matrix into the nodal displacement. Okay, so now we'll write the B, which you already calculated, 1 by 200, 1 by 250 minus 1, 1, and the displacement, nodal displacement like Qi, Qj. Right, these are the nodal displacement, where Qi I will write directly, that is 0.1. In the next step you have to write, so 0.2 is for Q2. Okay, like that. So now you need to make the multiplication so that you will get the strain displacement. So let us take the 1 by 250 as it is. Now this one minus 1 into 0.1. So it will be again minus 0.1. So 1 into 0.2. So plus 0.2. Okay. So 0.2 minus 0.1. It will be again 0.1. So 0.1 by 250 you have to make it. 0.1 by 250. So you will get the strain, that is epsilon value you will get. So it is 4 into 10 power of minus 4. Okay, so strain doesn't have any unit. Okay, so this is the solution for a short problems. So in any competitive exams, if you have the questions like this, so that you can easily solve by these tricks. Okay, so thank you one and all.